Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 62, unique paths. So after finishing this video, try by yourself for the path sum 2 because these both problems are are same. Okay. After solving this unique parts, try by yourself this unique parts too. Okay, don't blindly go and see the solution. Fine. So there is a robot on an M cross N grid. The robot is initially located at the top left corner, which means 0, 0. The robot tries to move to the bottom right corner, which means M minus 1 and N minus 1. The robot can only move either down or right or any point in time. Okay, given the two integers M and N, return the number of unique paths that the robot can take to reach the bottom right corner. Okay, so for example, if this is the grid, they have given that M value is 3, which means 3 rows, and N value is 7, which means 7 columns. For this, I can tell you I have 28 unique paths. You may ask, hey, what is mean by unique paths? Observe this carefully. Here I can either go like this, or I can either go like this, or I can either go like this. There are different types. There are different paths. Okay, that's the reason why my answer is 28 if I add everyone. Okay, for simplicity, let me take a small sized matrix. Okay, by doing this, you can understand this clearly. See here, it is what here the M value is of 2 and the N value is of 3. Okay, so this is the M and N value. Now my robot will be placed here and my destination is this. Yes. Okay, now how many ways I can go? First way is go along like this. Okay, so this is going to be a first way, and second way is like this. Yes, and then the third way is like go like this, then come down, then go right. Okay, so there are totally 3 different unique ways. So my output will be of 3 for the following M and N value. Okay, now from this itself we can clearly say that, hey, it is a combination type. It is a recursion program. Okay, whenever there is a recursion program, first of all, our mind will be going to frame how the function looks like, right? So function where I want row and column as my parameter compulsorily, because they are going to changing accordingly. So these two are the varying parameters I need. Okay, and how I am going to break this recursion? Before that, if you don't know about the recursion stack and recursion tree, please go and watch my recursion introduction video. I will be giving in the description. After watching that, just come and resume this video. Okay, now from here I can either go to down or I can either go to right side, right? So if I go to down, it will be function row plus 1 and column. If I go to right side, then row will be same but column will be plus 1. So this is how I will be dividing my main problem into a sub problem. Okay, and there are base conditions. Let us see everything. Now where should I start? I will be starting from the source, right? What is source? It will be 0, 0. Okay, now let me write the M and N value. M value is 2, right? 2 and N value is 3. Okay, so this is the M and N value. Okay, so first step, what I can do, I can either go to row plus 1 and column as it is, or I can go row as it is but column will be plus 1. This is the first thing. Okay, now go apart from that. I can either go to 2, 0, or I can either go to 1, 1. Here also I can either go to 1, 1, or I can go to 0, 2. So this is the next step. Yes, now observe this clearly. Here it is what? F of 2, 0. 2, 0 means whether we have anything like 2, 0. No, it is in a range like something. Let me highlight with using the white color here. So this row is the index number 2 and this column is the column number 3, right? Whenever I reach these boundaries, I want to just directly return 0. You cannot go apart from that. I am standing here. It is not valid. So from here I can tell you I'll be returning 0. Because it is not a valid path. Okay. Now you can understand one of the base condition. Okay. Let us proceed. Okay. Now 1, 1. From 1, 1 I can either go to 2, 1, or I can either go to 1, 2. Now I want you to understand this 2 comma 1 will be returning 0. Okay, now what about this f of 1 comma 2? F of 1 comma 2 is our destination. This is our destination, right? So whenever I reach my destination, I'll be returning 1. It implies, hey, you have came under the valid condition. You have came under the valid condition. Okay, fine. Now let us move on. Now here it is f of 1 comma 1, right? So here I can go to f of 2 comma 1, or I can either go to f of 1 comma 2. So here also it will be returning 0, and here it will be returning 1. Similarly here, from here I can either go to 1 comma 2, or I can either go to 0 comma 3. Now listen this carefully. 1 comma 2 will be returning 1, but 0 comma 3, whether 0 comma 3 exists? No, it is coming into this boundary. Okay, whenever it is coming out of the boundary, I will be returning 0. Now listen this carefully. It is going to be much more important part. Here it is returning 0. Here it is returning 1. What should I take? What should I take? Okay, you want to take all the unique parts. So I'll be adding them. 0 plus 1, which is equal to 1. Which is equal to 1. So it will be returning 1. Okay, again, here it will be returning 1 because 0 plus 1, again it will be 1. Okay, now similarly here, 0 plus 1 will be 1. So it will be returning 1. Here also 1 plus 0, which is equal to 1. Now again 1 plus 1, which is equal to 2. So here it will be returning 2. Now from this f of 0 comma 0, it will be returning 1 plus 2, which is equal to 3. So 3 is going to be my output. You understand this? Okay. Now tell me, what is the time complexity? So the time complexity required for me is 2 power n cross m. Okay, and space complexity will be O of n cross m. Okay, the time complexity is because the time complexity is exponential, because see here, for every recursion call, I am having 2 other recursion calls. Okay, that's the reason why for m cross n recursion call, it will be 2 power m cross n. Okay, and space complexity is because of the recursion stack. So always remember, there will be a recursion stack. Our auxiliary stack will be inside, which will be doing our stack operation in the recursion. Okay, fine. So now let us see the code, then we can return back. Okay, see here, this is the code. First of all, I am just having a helper function. Inside the helper function, I am just giving what 0 comma 0 as the initial value. Now here, what is the first base condition? If I reach the destination, then I want to return 1. Okay, or else if I out of my boundary, either in my row or in my column, then I will be returning 0. Okay, so these two are the base condition. And what is going to be body? So body of the recursion function going to be, hey, I want to go to down first. So which means row plus 1 and column will be same, or go for a recursion call for row as it is but column plus 1 and do a summation of these both and return up. That's it. Okay, so this is going to be your entire recursion code. Fine. Now let us take this and we can go and further optimize this code, because it will be not submitted successfully. See here, what is they have given? They have given that m and n value will be of 100. So it will be like 2 power 100 square, which is exceeding the 10 power 9. That's the reason why we are just going into a optimization technique called memoization. The next optimization technique is memoization. So why we need memoization, and how we are predicting we need a memoization technique here. So let me give you a sample. See here, here it is f of 1 comma 1, and here also it is f of 1 comma 1. As you know, our recursion is always a DFS approach, right? Our recursion is always a DFS approach. So it will be going like this, then come back, then going like this, then come back, then going like this, then it will be going like this, come back, going like this. So from this I can tell you, first we have computed this value. Okay, so if I stored in my memory, then when I'm encountering this again, instead of going to these recursion calls, I'll be just taking it. That's it. Can understand this? Instead of going again to a recursion call, I'll be taking from the memory and returning it. So it will be saves my time, right? So this is called the memoization. We are going to store everything in my memory so that in case in future if it is occurring again, then there I'll be just giving out the result. That's it. Okay. So there are few steps to do a memoization technique. The first thing is we want to construct the matrix. So in memoization we can do with hash map and also array. Okay, and also array. I am doing the array because array is more helpful for the optimization technique, but also you want to do using the hash map. The hash map technique will be more easy once I just given you the explanation on the arrays. Okay, just observe how the array is implemented, then implement the hash map. Okay, fine. Now the first step is we want to design the array. Okay, the first thing is whether the array is of how many dimensions, whether 1D array or 2D array or 3D array. So see here, first of all, how many varying parameters are there? So this R and C are going to be a varying parameter. So I can tell you there are two varying parameters. There are two varying parameters. So from this I can tell you we are going to design a 2D array. A 2D array. Now hope you understand how we are going to find out the dimension of the array. Okay, now the next step is we want to predict the size of the array. So see here, what is the row will be starting from 0 and column is also starting from 0, and they will be going up to what, m-1 and n-1. So from this I can clearly tell you we want to start from 0 up to m-1, which means we want m cross n array. So for input like 2 cross 3, for the input 2 cross 3, or for the input m is equal to 2 and n is equal to 3, then I want an array of size 2 cross 3. Okay, 2 cross 3. So this is what the array size. Now we have successfully done the dimension and the array size. Now the next step is what is going to be the initial value of everything. Okay, that's going to be more important. Okay, for that go to the constraint and check there is nothing, right? Nothing here. So you want to design like whatsoever value that is returned here should not be equal to the initial value inside. So I can tell you always the 0 or positive value will be returned in this tree, right? So from this I can tell you, hey, we can put a negative values, -1 or 2 or 3, anything, or else you can put infinity. Okay, or else you can put -infinity, or else you can put null, anything, right? So I am going to put -1. If you put anything, then that should be same for every in this. Okay, fine. So now we have successfully done our memoization array. Now the next step is add one more base condition here. What is that base condition? If dp of my row is r, right, r, and column is not equal to -1, then just to return the value that is computed already. Okay, now in this return statement also you want to do one step before it. So in my current index of the dp, I want to store the recursion value. So what is the recursion value? It will be r plus 1 and c plus solve of r and c plus 1. Okay, now next step I will be returning it. That's it. Can you understand this? So by doing these things you can just do a memoization for the recursion code. Okay, so in this line you are just checking whether the particular index is -1. If it is not, then it is already computed, right? It is already computed. In these two lines, I'm just updating my values. That's it. Okay, now tell me what is the time complexity. So I can tell you the time complexity will be O of m cross n and space complexity will be of m cross n. So it is way optimized, right? Okay, now the space is because of array we have used and also the recursion stack, right? If I want to further optimize it, I want to eliminate this recursion stack, right? So eliminating this recursion stack, and instead of recursion we are going to use a looping. So this method is called tabulation. So tabulation means what? Instead of recursion we are going to use looping. So this is going to be the tabulation. Before that, let us see the code. So this is going to be your memoization code. So see here, first of all I want to take the array, okay, the 2D array. then I want to initialize everything as -1. If you want -2, if you want infinity, if you want minus infinity, but you cannot do a positive numbers or 0. Okay, because they are occurring in our return function. Okay, now I'm doing a just same as the recursion. Now inside that this two base condition is same, but the only base condition differs this line. I have already explained it in a drawing explanation, and also these lines. That's it. Okay, so this is going to be your overall memoization code. Let me just get this code. In this memoization, we are now going to still optimize it to give the tabulation. So observe here. So these are going to be your tabulation method using the array. Okay, you can do using hash map and also array. I'll be showing you the array approach. You want to try the hash map by yourself, because array approach will be helpful in further optimization. Okay, now listen this carefully. The first step is we want to check whether we want to alter the size of the array or not. Okay, so initially what is my m value as of now? It is 2 and n value is 3. So take this for an example. Okay, now according to the memoization, I want 2 cross 3 array, right, or matrix. So 0 1 0 1 2. So this is what in the memoization, but in tabulation we want to check in the base condition. So the first base condition is if r is equal to m minus 1 and c is equal to n minus 1, then return 1. So whether I have m minus 1 and n minus 1, yes I have. So this is going to be the m minus 1 and n minus 1 as of now for this input, right? So here I will be making what? Here I will be making what? 1. Okay, and here if r is greater than or equal to m or c is greater than or equal to n, then I want to return 0. Okay, but here we are not going apart from this, right? So we can ignore this base condition and also just strike out this base condition, because this will be not helpful while converting into tabulation. Now these two lines are going to be my body of the tabulation, body of the recursion, right? Now whenever we encounter the body of the recursion, we want to go for a looping. So for r will be from where to where. Here the r will be from 0, it going up to m minus 1. So here it will be starting from m minus 1 going up to 0. Understand this? So this is how we want to change. Okay, now c is equal to n minus 1 up to 0. So always do a reverse fashion. If it is from 0 to n minus 1, then do n minus 1 to 0 in the tabulation. Okay, now what is the next thing? Next thing is observe this clearly. Whenever my r is equal to m minus 1 and c is equal to n minus 1, then I want to return 1. I don't want to do anything. But here at first iteration itself, r is equal to m minus 1 and c is equal to n minus 1 only. So at this particular point, I want to skip. Can you understand this? This is going to be more important. Okay, so don't forget it. At this particular point, I want to do what? I want to skip it. So continue. So many of them will be doing this mistake here. Okay, fine. Now what is the next step? Next step is go to the body. So take this dp of r and c is equal to the first step is here it is solve. It is going to be the recursion call, right? So whenever it is a recursion call, make it like dp of here comes row plus 1 and another changing parameter is c. Similarly here also dp of plus, okay, plus here also similarly dp of, because here also it is solved, right? So what is the varying parameter? It is r and another varying parameter is c plus 1. That's it. Okay, but here there may be of one edge condition. What is one edge condition? See here, if r is equal to m minus 1 and c is equal to something like 1. Okay, now r plus 1 will be leading to m. Whether m is an index in this dp array. No. So before initializing it, we want to check whether it is there or not. For that only, I am going to introduce you some two variables. So it is not a big deal. So see here, listen this carefully. Instead of doing this, first I will be taking it down. What is the condition to go down? So here this first thing is down condition, right? So here I want to check if my dp, sorry, if my r plus 1 is lesser than, is strictly lesser than m, then only take dp of r plus 1 and c. Okay, else what should I take? Take 0. Take 0, because whenever it is out of bound, I'll be returning 0. That's the reason why here also I'm just taking 0 as the down. Now similarly for right, if r plus 1, sorry, c plus 1 is lesser than n, strictly lesser than n, then only take dp of here r and c plus 1. Can you understand this? Okay, at last dp of r and c is equal to down plus right. That's it. Can you understand this? Why we are including these two conditions? Okay, now at last what should I return? What is the return value? So see here what is the return value? It is solve of 0, 0, right? So after doing everything, I want to return dp of 0 and 0. That's it. So this is going to be your entire code. Now tell me, what's the time complexity? So time complexity will be O of m cross n, and space complexity will be going to be m cross n as it is. So it is because of the matrix we have used. Okay, now let us see the code, then we can go and just see the further optimization. So see here, this is going to be a tabulation code. Everything is similar. Here I haven't initialized anything because at the end anyhow we will be updating it. We are not going to be doing anything like adding at that particular index like that. Okay, we are going to updating it. That's the reason why I not initialize anything. Okay, and at the last index I have initialized as 1, and rest of them are similar to what I wrote in the drawing explanation. Okay, fine. Now let us get into the next approach called space optimization approach. So why we need a space optimization approach? So it is so simple. Whenever we don't need any extra space, then we will be eliminating it. So that's the reason why we need a space optimization technique. Number 4 is space optimization. Okay, now see here. Now you want to tell me what are all the extra space we have taken. So see here dp of I plus 1 is required, and dp of I is required, and here also dp of I only required. Apart from that, we don't require anything, right? We don't require anything, which means this implies if my m value is 1000 and n value is of 100, which means 1000 cross 100 matrix we need as of the tabulation method. But by seeing this space optimization trick, we can tell that we need only 2 cross 100, which means 2 cross column sized matrix. Okay, which means what I am just telling you that, see here we need my next row, here we need current row, here we need next row, here we need current row. From this you can clearly state we need only 2 rows. That's the first observation. But the next observation is whether we need this 2 rows also. Okay, so you can blindly see here down we need dp of I plus 1 and j. Similarly for right, we need dp of I and j plus 1. So from this I can clearly state we just going to update each and every other, right? We just going to update it at the end. So I can just put dp of j and dp of j plus 1, and here also dp of j. And here I'll be taking only one dimensional array. So it is like strike with this. What I'm telling you is, instead of this, I'll be writing dp will be equal to only n, which means column alone. Okay, now similarly here I'll be writing like dp of n minus 1 is equal to 1. Okay, and then in these 3 lines I'll be writing like down is equal to all conditions, and after this question mark I'll be writing like dp of j and rest of them. And similarly for right, I'll be writing everything as similar from this line. After question mark, I'll be writing like dp of j plus 1 and rest of them. At last, here also I'll be writing like dp of j is equal to down plus right. That's it. That's it. After everything, I'll be returning what? I will be returning dp of 0. Can you understand this? Can you understand this? Like, we only going to store the down value in my down variable, and I'm going to store my right value in my right variable. Then I'm going to update them in my dp. Okay. Then why should I need two values? My previous value will be stored as of here only, right? So from that itself, I'll be just updating here. That's it. So that's the concept I have written here also. So let me show you the code. See here, this is going to be the code. Can I understand this? Can I understand this? Right? So here I didn't took anything. I just initialized my dp as only of n size, which means columns, and last value will be 1. And inside also I only write like what? Instead of dp of I or I plus 1, I written like dp alone. Here also dp alone. Okay. Here, since we don't have I have just strike out the condition, and at last I'll be just writing like dp of j is equal to down plus right. And at last, instead of returning like dp of 0, 0, I'm just returning dp of 0. Can I understand this? If I submit this, yes, it is submitted successfully. So I want you to dry run this space optimization code so that you can understand this clearly. Okay. Now tell me, what is the time complexity we require at last? So now my time complexity will be of O of m cross n, but my space complexity is only of O of n. So this is the way optimized than the recursion code. So this is the dp. Okay, so I have completed you all the 4 approaches and optimization techniques for you, and now your job is to just go and dry run each and every approach using some examples so that you can understand this clearly. Okay, and dp takes time to learn. Okay, if you really like this video, subscribe to my channel and don't skip any videos in this dp series, because all dp series will be helpful once you are going for a competitive programming. And if you want to know about these kinds of algorithms, just go and search in my YouTube channel. If you have any doubts, just comment below. I'll be commenting the answers. Thank you.